And welcome to the lesson on integer points on regions. So we'll do these problems as if it was without calculator, but have your TI by handy because we'll probably check our answers with calculator just as a backup in case it happened to be a calculator exam. So integer points on regions. So I'm just going to be typing for this lesson. So let's give us a nice color to type with. Let's use purple. So integer points on regions. And let's make the text a little bit smaller. 18. So flashback from year 10, what is the definition of an integer? So have a think for yourself, an integer, as opposed to a regular real number. Integers are positive and negative whole numbers. So integers are positive and negative, specifically whole numbers. So that's important to remember that. So from year 10, well, that was a definition of an integer. Remember your different types of numbers. You had real numbers, you had, which is in our case any number in our particular course. You have integers, which are positive and negative whole numbers. You have natural numbers, which are positive whole numbers, could include 0, might not include 0, depending on the course you're using and the textbook you're using. You also have rational numbers, which are any number that are not irrational. So irrational numbers are numbers like pi, square root of 2, square root of 3 over 4, e, the exponential. They're numbers that have an infinite amount of non-recurring decimal places. So therefore, back to here, therefore what do you think what we mean by an integer point on a graph, like an integer coordinate? So trying to think of graphs, and integers are positive and negative whole numbers. So if it's a coordinate, that's an integer coordinate or an integer point. So you can say it is a coordinate to start with, where both the x and the y value are integers, positive and negative whole numbers. Some examples could be, e.g., something like 3, 5, or like negative 204, brackets 1, so long as it's a whole number. So not something like 1.5 brackets 3, or something like negative 3.67 for 9.28. So basically where the x and y value of the coordinate is a integer, a whole positive or a negative whole number. So that's a good little recap on some past facts. So how many points in the regions below have integer coordinates? So remember the regions we've marked with an R. Regions have been marked with an R, and an R. So that's what we mean by the regions in these examples. So what do I mean by integer coordinates? Let's see. I'll actually kind of type them in. Notice this one's their solid lines, so they do include the lines. Well, we have an integer coordinate here because it'll be 1, 2. We also have an integer coordinate here, 1, 1. We also have 2, 1. We have an integer coordinate here because it does include this point, because see x plus, oh goodness me, x plus 4 equals y, x plus y equals 4. This is just the line y equals 4 minus x. So it would go through this point, and it's not a dashed line, so it does include this point. This line would go through that point. It's got a y-intercept of 4, so it does include these points. It does include these points because there's a solid line here, assuming that it's not a dashed line. Does it include this point? Let's see, what would be the x-intercept of this line? The x-intercept of this line would be 4, and it does include that point. So let's see, how many points did we end up labeling there? Let's see, we end up labeling, have a count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we ended up having 15 integer points on that particular region. Let's do the one below again. So I'm going to do the one below that because these ones all have solid lines, so it's pretty clear. Most of the time, if you see a problem like this, it's with a solid line. You don't really see them in our course with dashed lines. So solid line, here we go. So let's see, only include the integer coordinates. So here's 1, here's 1, here's 1. These ones are pretty definite because they're definitely within the region labeled R, the unshaded area in this particular example. So I'm doing those ones first because they're definites. Then the ones in the corner, you've got to have a little think according to the line. And that one there. So here there's no dashed line here, so we're assuming that does include the line y equals 0. So we'll put dots on these ones. There's a lot in this particular region, isn't there? There, that. Now, does that line go through here? Let's see. The way we can check that it definitely goes through 8 is we can try working out what the x-intercept of this particular line would be. So the x-intercept of this particular line, if you, at the x-intercept y is 0, so you would plug in y is 0. What am I doing? I'm trying to find the x-intercept. Okay, so x plus what equals 12. So x would have to be 8, because, hang on, what am I saying? Sorry, this equation here relates to this line. So the x-intercept of this one, so we should be looking for the x-intercept of this line here, which is this equation. So subbing in, remember the x-intercept y is 0, so sub in x plus 0 equals 8, so the x-intercept is at 8. So it does include that point. Lovely. Now let's see, does it include this point? Let's see, so if you plugged in x is 7, 7 plus 1 equals 8, so it does include the coordinate 7, 1. Does it include this coordinate here? It's getting a little bit tricky now, isn't it? So I've given you a bit of a rough example. I'll also point out that we do need to include these ones because we've got solid lines here and here. So let's do them first. Which one is this one? What is the y-intercept of this particular one? So remember the y-intercept, x is 0, sub in 0, so therefore 3y equals 12. The y-intercept therefore is 12 over 3, which is 4. So it does include that point. Does it include this point? Error. Okay, so try subbing in. Let's see, does the coordinate 3, 3 exist? Sub in 3 here, and sub in 3 here. 3 plus 3 times 3 is 12, so it does include that point. Does it include this point here? Sub in 6 and sub in 2. So let's see, x is 6. 6 plus 3 times 2 is 6 plus 6, which is 12. So it does satisfy that, and according to this one too, 6 and 2, 6 plus y is 2 equals 8, yep. So it does include that point. That was tough. Doesn't include this point because that's not part of the region. Now we've got to count them all up. So we've got 1, 2, 3, 4, sorry, count again, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Hopefully I've got that right because I did that pretty rough. So we've got 29 integer points. That's all we were trying to find there. So now we've got to do the one above. Okay, so looks like it's bound by this line here. It's bound by the line x equals 0. It's bound by the line y equals 0. So it doesn't, and they're not dashed, so it does include these points. Of course, it includes the points that are inside the region labeled R. So we can mark all these ones first if you want to get them dealt with, the obvious ones. And then this one. Then we've got to decide, does it include any of these points? The thing is, it doesn't, it's a dashed line, so it doesn't include that point. So we can automatically say, no, it doesn't include that point. Doesn't include that point. Doesn't include, kind of does, maybe a little bit because of that line. Okay, I'm doing this very roughly. Generally, you tend to see these questions more like this, where you've got solid lines, so you don't tend to get these horrible dashed line questions in our course. So let's count up what we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 integer points. You can tell I'm trying to move on from this because it's taking longer than I thought. Integer points. There are a few questions like this in the textbook though, which is why I've included some like this. Now let's move on to what's really important, is this. So below is an exam question from 2015, June paper 4, area 2, because there's 3 different types of areas. There's area 1, 2 and 3. So you had a little graph and the instructions are below. So obviously they want you to do something with that graph. On the grid, show clearly the region defined by all these inequalities. So you might remember from the TI Inspire lesson, you can possibly be asked to graph 4 different lines and kind of work out which region satisfies all of these inequalities at the same time. So you want to start by plotting the lines. Notice all of them have got the greater than or less than and equals to sign. So they're all solid lines. So that's something you might want to notice, make a point of. These are all solid lines. That kind of helps a little bit. No need to decide either dashed or solid, just solid is all they are. Let's do the first one. X equals -1. We need to do a solid line through x equals -1. I might just zoom out a little bit so I can see the whole graph a bit easier. Kind of. Okay, so now we're doing x equals -1. Let's see if my line tool is going to work nicely. And I might do that with a nice red. -1. I really hope I've hit the right point. If not, I can adjust it later. You make sure you use a ruler. Is that on -1? I hope it is. Yep. So I should now label this little point here. X equals -1. I'm going to label it in red. So that line is x equals -1. Is that equation? In terms of shading, you kind of want to have a vague idea of your shading. So the region, remember the way we indicate our answer is with an R. So don't worry too much about your shading, but the shading's just so we realize where is the overlap. So x is greater than or equal to -1. So x values which are greater than. So that means all the ones over here. So if you really want to, you could shade. I'm just going to do a vague shade in red, but I'm going to unshade it. So it's meaning this bit over here. I'm going to now unshade that because that looks like a real mess. So if you've shaded yours nicely, hopefully that's okay. And then the next one we're going to do is y is greater than or equal to 2. So we first did x is equal to -1, which was a vertical line. Y is equal to 2 will be a horizontal line because vertical lines cut the x-axis and horizontal lines cut the y-axis. So I'm going to do this one with blue, and again it's just a nice solid line. So I'm going to do this one in blue, and the value for it is 2. Let's see, hopefully is this going to, no, I'm going to have to adjust it later. It's okay, I can do that with my line tool. I need to move it down a bit. Come down, here we go. There we go. Lovely. Lovely, lovely. And now I've got to label it. The line is y equals 2. It's not -2, it's y equals 2. So let's label that y equals 2. Which region would that be? So it's saying that y is greater than or equal to 2. So it would be this region up here. So everything above the blue line is that region specified. So the region that these two have in common, when you think of it, it's all the ones over here would be red, all the ones above the blue would be blue. So which area would have been shaded twice, therefore purple? It would be this region here. So this kind of little quadrant here is what's they have in common so far. But we need to graph the other two first to see what's in common to all 4 of them. So next one is y is greater than or equal to 2x minus 3. So we've got a y-intercept of 3. So you might just want to make a little note of that. I'm going to type that, when we're going to type that down here, I'm going to type it in green. So we can say y-intercept equals -3. That's something that's kind of cool to know, make a point of. Okay, come back here. Okay, just moving that there. So the y-intercept equals -3. So we can plot that. So I'm going to plot that right here. Y-intercept of -3. And then you can use the gradient to plot another point or two. You could also find the X-intercept. The X-intercept, you would just plug in y is 0. So the X-intercept would be 3 over 2. But you could also use a gradient as 2, so that means go up 2 across 1, up 2 across 1. So from -3, I'm going to go up 2 and across 1 and plot that point. It's kind of hard to see on this graph, sorry. Next one, go up 2 and across 1 and plot that point. I think it's right there. From here, I could also go down 2 and across 1. Here's another point. And then down 2 and across 1. So really hard to see. You can always use a ruler for yours. So I don't know, somewhere around there. And then we should rule a line through all those points. So I've used the gradient is 2. So the gradient is 2 over 1. You might want to write that the gradient equals 2 over 1 equals m. So we're going to cross 2 and down 2 across 1. Now let's plot that with our lovely line tool. Use the green line tool. No, just make it brighter green so that you can sort of see where the dots were. A bit dodge. And I might have to adjust mine a bit. It's not too bad. There you go. I just really want to go through the Y-intercept, and we should label it. So this one's going to be whatever it was. What was it again? Y equals 2x minus 3. Makes sense. Positive gradient. Y-intercept of -3. That's our equation. Y equals 2x minus 3. Being really nice and thorough here, labeling everything very clearly, as we should. Just going to quickly save before we have our final one to do. Nice. And by the way, that is y values which are greater than 2x minus 3. So y values greater than 2x minus 3 would be all the area above here, above the green line. Y is greater than. So remember, the areas that are shaded so far are to the right of the red line and above the blue line and above the green line. So the area that they have in common so far is this one here. That would be the region so far. So this region here is what they have in common. If you need to shade at all to do that, feel free to do that with your grey lead pencil. Just shade really lightly. Last one to do is this one. So if it was with our calculator, we could easily graph it. I would suggest find the X and Y-intercepts. Remember how we do that? So X and Y-intercept. Let's set up a nice little table. Do that here if you want. X and Y-intercept is our X-intercept. You could also rearrange it to make it y equals, no problem with that. I'm just fond of this method. When you've got it in kind of this kind of form, I prefer the X-intercept and Y-intercept table method. It's just taking me ages to write like this, so Y-intercept. I think I might start to try to type. I'll just type really small so we can fit it in there. What color am I going to type this in? I'm going to do this one in, done purple yet? No, we haven't. I'm going to type this one in purple. So remember, at the Y-intercept, x equals 0. And so you could do the X-intercept first. My cursor just landed here. So at the Y-intercept, x is 0. So your equation would be 3x plus 5y equals 30. So therefore you would say 3 brackets 0. Oops, 3 brackets 0. What is it? Plus 5y. Plus, so much easier when you're writing. 5y equals 30. So there you can say 5y equals 30. So you could say y equals 30 over 5, which is 6. So, and then now do the other one over here. For this one, we can say at the x-intercept, y is always equal to 0. Next one, so we can say, if the equation is 3x, so we can say 3x plus 5y, so y is 0, so let's plug in 0, equals 30. So therefore 3x equals 30. 3x equals 30. So would you agree, therefore, x equals 10? Lovely, and now you might just want to write those two as coordinates. So I'm going to write them as coordinates with my dodgy pen. So this coordinate would be 0, 6. Good to practice our coordinate geometry, our graphing, by doing all this. And this coordinate would be 10, 0, because remember you write the x first and the y second. 10, comma, 0. I don't have space really below to write it, so because I want to put my answer later on there. So let's plot those 2 points. The x-intercept is at 10, 0, so here's our x-intercept. Lovely. And our y-intercept is at 0, 6. So let's plot our y-intercept. 0, 6. And now let's draw our line. So we're going to draw a line using our line tool. I might use a nice move. Okay, through there. And I need to fix it up. That's better. Kind of extend your lines, because you never know where the regions they have in common are going to be. And I need to type in what that equation was. What was that equation? Just 1 second. It was 3x plus 5y equals 30. So I'll go back to 18 point. 3x plus 5y equals 30. Phew. So you might kind of also want to think, okay, if you rearranged the inequality below, like I'm trying to work out, is it the region above or the region below? So to work out if it's a region above or region below, remember the quick method we used in another lesson was sub in the coordinate 0, 0. And see, does that satisfy it? So if you plug in 3 times 0 plus 5 times 0, but we need the inequality back here. 3 times 0 plus 5 times 0, that gives you 0, of course. Is 0 less than 30? Correct. Yes, it is less than 30. So that's a quick way, when you've got this standard form, to see that it's the region below the purple line that satisfies this inequality. So another way you could do it is you could rearrange. 5y equals 30 minus 3x. So, sorry, using the inequality version. 5y is less than or equal to 30 minus 3x. So y is less than or equal to 30 minus 3x over 5. So less than or equal to, so is y, so it would be the region below. So that's wicked. So the region that we're looking for, because they want us to say which region is defined by these inequalities, it's the one in here. So it's the region here that is satisfied by the inequalities. So because if you shaded all of them together, as we said, then this area would have been the overlap, because it's the area to the right, because its x is greater than -1. It's the area above the blue, because its y is greater than 2. It's the area above the green, because its y is greater than 2x minus 3. I should have had an equals there, by the way. Give you that up. That up. There you go. That should have been an equals in there. So it's the area here and the area below the purple line. The area below the purple line. So the area that is intersected 3 times, or sorry, the area that would have been shaded 4 times is the area that's our answer. So I'm going to select my lovely yellow pen. I'm going to write R to indicate the correct region. So that's finally answered this question here. So unfortunately we're not done yet. Use your diagram to estimate. So note it says use your diagram. So you're forced to use your graph. So it's up to you in terms of, it's got to match whatever you've got on your graph. Use your diagram to estimate. Estimate means maybe a range of values are kind of okay. Just the most accurate you can possibly be according to your graph. So from this region that we've kind of labeled R, use your graph to estimate the greatest value of y in the region. So the greatest value of y in the region is, remember this is the y-axis, the greatest value of y in this region is going to be the highest point. So the highest point of y, you could have a look on your graph, the highest point of y is right here. No need to, I'll just put a little dot there in case it's of any help. Highest point of y is right there, and if you read across, it's going to be, what's that, 6 6.6, something like that. I'll show you the official answers say anything between 6.5 to 6.7 according to your graph. And also it has to match whatever you've got on your graph. So mine seems to be around 6.6. So I'm going to say y is 6.6. So I got that from this point right here. 6.6. Let's type it in. Oh dear. 6.6 is my estimate. And then use your graph diagram to estimate the greatest value of x plus y in the region. Maybe we do that with orange this time. The greatest value of x plus y in the region. That's a little bit trickier. Let's see. So you could have a little estimate. Is at this point here, if you added its x coordinate and its y coordinate, what would it get? So if you added these two together, you'd get the x coordinate is -1, and this one is about 6.6. What's -1 plus 6.6? And you could always show that working out. Ooh, dearie me. Show that working out down here, just to be on the safe side. Let's see. -1 plus 6.6 equals, what is -1 plus 6.6? It's 5.6. Let's see if we can find a coordinate where if you added its x and y together, you would get a higher value than that. Let's have a little look. Cool, the orange is still working. Sort of around vertices are where you could get extremes. It's not going to, like, it's got to be within the region too, by the way, in case you were wondering what's going on. Could it be this one? Nah, that's going to be pretty small. That's going to be something like 2 point something plus 2 point something. That's going to give us 4. What about this one? That's going to be really tiny. That's like a -1 plus 2. That's going to give us 1. So that's super small. Maybe it's this one. Let's see. What would be the coordinates of that point? Yeah. It would be around 3.4 for our x and about 4. 3.4 for our x and a 4 for our y. Let's double check that one more time. Yep, about 3.4 for my x and it's hard to see, 4 for my y. 3.4 plus 4, let's see what that's going to give us. 3.4 plus 4 is going to give us 7.4. That seems to be the biggest, doesn't it? Your vertices tend to be like your corners. If you forget what vertices are, your vertices, your corners of your region tend to be where you're going to get these kind of extremes. Like a minimum value would be that point. So it seems to be the maximum. That one ended up being 5.6. This one ends up being 7.4. So the highest value in this region of x plus y, through a little bit of experiment and kind of logic using the vertices, is going to end up being this one, 7.4. So let's write that in. 7.4. So a little tick here because it was that one. Okay, pretty weird question. Try to think, how could you use your graphing calculator to maybe just do a really loose check to see if you've kind of got the right answers here. Just reminding you that you can use your TI Inspire. If this was a calculator problem, you could just go for it, couldn't you? Let's quickly enter them all. I need to make sure I've got my inequalities up. That's what I'm doing there. So remember, you go delete and just select anything, delete it off, and just start from scratch. X is, don't like that, ew, goodness. X is greater than or equal to -1. So X is greater than or equal to -1. So you see it's kind of shown you that one, the one that would have been shaded after the red line. Next one is Y is greater than 2. So let's go for that. Y is, control that, greater than or equal to, sorry, 2. Downward arrow. And you can, if you can't see it, see it's kind of showing you the purple part that's shaded there. Double click to open again. Now we're going to do y is greater than or equal to 2x minus 3. Y is greater than, let's get nice and fast at doing this, and accurate hopefully, 2x minus 3. Yep, so see everything above the green line was just got shaded there. So at the moment the part that they've all got in common is this big part here. Now let's enter in our last one, which is 3x plus 5y is less than or equal to 30. 3x. So if you don't type in things correctly, obviously things are going to go wrong. So always check what you're typing in. And this time it's less than or equal to 30. So it should be this one. Always have a look at it before you graph it. See, did you type in the right thing? Cool, groovy. So that's kind of hard, a bit messed up to see on here. But yes, you can see just in general, this is kind of the region that got shaded 4 times. So it does kind of look like what we've got here. You could also do all sorts of graph tracing as well. So notice I can move it up here. You might want to check the coordinates of this. You can do all sorts of tracing. And you can go menu, analyze graph. You can trace, do all sorts of things if you need to inspect some vertices or anything like that. Ew. Okay, so that's how you generally check if it was a calculator problem, your graph. So just in case you didn't get the hang of that, you might want to pause and try this one for yourself now. I made up a new one, similar kind of problem, based on the past exam problem. Notice that they're all solid lines again, because that's what you generally sort of seem to see in these kind of problems. It'd be pretty mean. Solid lines only in this particular problem because of the nature of the inequalities. They've all got the an equal to sign on there. So you would have to graph them all. So let's try graphing them again. Y is greater than or equal to 0. So that's basically a horizontal line that cuts through the x-axis. So I'm going to do that one in red. Maybe so feel free to pause and try this one yourself. And you can just check with kind of what I've done at the end. Here it is. Now let's label it. Label it in 18 point red. So label y equals 0 is the line, technically. Oops. Equals 0. And it's saying y is greater than or equal to 0. So it'd be all of the above part here. All of the above part here. Next one we need to do is x is less than or equal to 10. So again, if you wanted to, you could lightly shade that, just as a way of keeping track of which region should be shaded. But as you can see on the computer smartboard, I don't have a nice pencil to shade with, so that's why I'm not doing it, or else it looks yucky. Next one, x is less than or equal to 10. So it's going to be a vertical line through 10. So I'm going to do that one in blue. Let's do this one in blue. Roughly through here. That's about right. And let's label it. Label it in blue. It's a vertical line and it's x equals 10. Always double check, like should it have been x is negative 10? Like just make sure you read it properly. The next one is x plus y equals 6. If you were to rearrange that, just out of interest, that's an easy one to rearrange in terms of graphing. That's just going to be y, we'll do it in orange, I want to do it in green. That's just y is less than or equal to 6 minus x. Easy to graph. It's got a y-intercept of 6 and a gradient of -1. So plot your y-intercept of 6 and gradient of -1. You could also work out the x-intercept. When you plug in the x-intercept, y is 0. You end up getting an x-intercept of 6. You can see that's easy to do. You could also go down 1 across 1, plot a point. Down 1 across 1, plot a point. But I'm in a rush, so I'm going to quickly plot that. Make sure it goes through a fair bit. I'm going to need to neaten mine up a bit. Make sure it goes through the right point. My x-intercept is 6 and my y-intercept is 6 if you work it out using the table method. Yeah, it makes sense. Y-intercept is 6 and it's a negative gradient. And I haven't labeled it, have I? No. So we want to label that. Green. Y equals 6 minus x. Or x plus y is equals 6. Either one you could label it. The rearranged version. Or you could label it as x plus y equals 6, the original version. And which part would be shaded? Again, like with the blue one, x is less than or equal to 10. It would be this area here. So it's all the area above in red because it's greater than 0, but x is less than 10. So x values that are smaller than 10, like 9, 8, 7, 6, and so on. So it's this area here. And for this one, when you rearrange it, it's y values that are less than the line. 6. So this one here. So at the moment we seem to have some overlap of, this seems to be the region that they have in common so far. Oh, my line's gone a bit off, hasn't it, here? Let's fix it up. Make sure your line looks good. Let's neaten that up a bit too. Okay, that's better. So it seems to be this region here is what they have in common. I realize I made this up, so I haven't actually checked that there is a region common to all 4 of them, so I really hope there is. Okay, now that we're doing this one. So now we've got 2y is greater than x minus 4. You can use the X and Y-Intercept method if you want, or you could rearrange it, up to you. I'm going to do this one in purple. So if you rearranged it, you would get y is greater than or equal to x minus 4 over 2. So this is kind of an awkward one in terms of the rearranging. So y is greater than or equal to a half x, because x over 2, a half x minus 4 over 2, which is 2. So a little bit risky in your rearranging. So you might have been better off just using the X and Y, X-Intercept and Y-Intercept table method in that particular one, using 2x equals x minus 4. Much safer, to be honest, because there's a bit of messy rearranging there. And so on. So now we need to plot that. What am I doing? Okay, so it's a Y-intercept of -2. Y-intercept of -2. Here we go. And our gradient is positive a half. So you can go up 1 across 2. It's about there. So positive a half. So go up 1 across 2. Positive a half, go up 1 across 2. About here. Same from here, you go down 1 across 2. Where's that? Is that about there? Okay, done very roughly again, sorry. Now let's plot our point. Using our nice colours. Nice. What will I use this time? Let's use that one. Going through here. It's reasonably okay. Neaten it up a little bit. Let's plot our thing, our equation. Our equation for this line is 2y equals x minus 4. 2y equals x minus 4, nice. And remember when I was and a quick way to check, is it the region above the purple line or the region below the purple line? Plug in the coordinate 0, 0, which is right here. Coordinate 0, 0, and does it satisfy the inequality? So 2 times 0 is 0, 0 minus 4 is -1, is 0, -4, sorry, is 0 greater than -4? Yes, it is. So it means that the region that has the coordinate 0, 0 is the region that you shade, that it would be shaded, which is the region above the purple line. Makes sense too, because the rearranged version is y is greater than that line, so it's that version up here. So if you shaded, try to think if you shaded, let's see, so if you shaded all of above the purple, sorry, all of above the red, and all of to the left of the blue, and all of which is it above or below? Below the green, and all of which is above the purple, which parts would have been shaded twice? I mean, all 4 times. And let's see, it might have been kind of this region here through to here. So not including this part. This part's not part of the region. That's what's kind of awkward. And this part here. So it's a bit of an awkward one where it's not super easy to point out where the region is. So it's kind of, it's got to be above the red, so it can't be below the red. The region, so as I said, it's got to be above the red. It would have to be not up here because it's got to be above the purple, and it's got to be below the green. It goes all the way out to here, to the edge of the graph kind of thing. So you would have shaded, like, remember according to the textbook, the unshaded area is the answer, so you would shade the non-region. So just make sure the region doesn't include that part here. Okay, again, you can test it with your graphing calculator. Feel free to do that. You might want to quickly pause. I'm going to pause. You do that now. You check it with your calculator, and I'm going to pause and do it with my calculator now and show you the result. Okay, cool. So now you can see the part that I've shaded. So the part that is the region is the part that's kind of above that line there, and also, as we said, below the green line here. The part X is 10. X is 10 is over here, so it's basically all of this area. So notice it is correct. It's kind of like going up to here, down to here, down to here, cuts up here, and then goes across there. So it does not include this little triangle here, so that's not part of the region. So we've just checked our little answer there. What we have to use, again, it says use your diagram to estimate. Use your diagram to estimate. Don't do it any other way, according to this question. So I didn't say use your diagram, you could use alternative methods. So use your diagram to estimate. Have I labeled the region? Yeah, I have. Cool. The minimum value of X in the region. So according to our graph, I've kind of made a dodgy one. I should have made one where I had a border here. But in this particular case, you could say maybe negative infinity. We're assuming it goes on to negative infinity. The X, but normally they'd give you something kind of straight up. So if you did by accident say -3, it's probably not a big deal. So we could say minimum value of X in the region, negative infinity, in this kind of dodgy example. Normally they would give you one, as I said. Maybe I should have said what's the maximum value of X, in which case it would have been 10. One where there's the maximum value of X in the region would have been this coordinate here, whatever the X coordinate is. So if it was the maximum value of X, it would have been this coordinate, and you would read down, it would have been about 5.4. But I asked you for the minimum. In hindsight, I should have said the maximum. Another thing you're asked to find is the maximum value of 2x plus y for all x, y in the region with integer coordinates. Don't worry about that. Actually, cross that out. Actually, no, we want in the region. But with the integer coordinates part, let's just ignore that. It's not something you tend to be asked. So the maximum value of 2x plus y in the region. So if that's confusing you, just cross it out. In the region, then it looks more similar to the exam question we just saw. So 2x plus y, holy moly. So again, we kind of want to look for extremes, and we're asked to use our diagram to estimate. So if you doubled the x and added the y, let's see, maybe it's this one. Double the x, 5.4 times 2 plus the y, which is 0.6. Let's see, okay, so let's try that one out. 2 times 5.2, I need to get this going on. Let's see, because it's 2x, 2 times, was it 5.2 or 5.4? According to that, it's about 5.4. So 2 times 5.4 plus whatever the y was for that was plus 0.6. What does that equal? Showing where the 0.6 came from. 0.6 or 0.8 or 0.7, whatever your graph says. So 2 times 5.4, have a think, that's 10.8. 10.8 plus 0.6 is 11.4. So we'll have to decide, is that going to be the maximum value? Let's try something else. So 2x plus, let's try, well, the problem is, again, it's a bit of a dodgy question because it goes on forever here. I should have had a boundary here that kind of makes it kind of clear. So at this point, we'll just say it's 11.4 because we don't know, like, it really does go on forever and infinitely this way, although doubling a negative number is going to make the number small overall. If you did 2x plus y for this particular point here, 2 times the x, 2 times 0 plus y is just 6, so that's a smaller number than 11.4. If you use this point here, that's kind of roughly at about 4. So 2 times 4 is 8, plus 0 is just 8. So that's not a big one. So it seems to be 11.4 is our answer. We'll go with that for now. So all I'm trying to do is say tick yes, it's done. Okay, thank you for your patience with that. And it's finally over and out.